Hi bachcho, welcome back to my channel with me. I'm your mystery teacher, and today we are going to be dealing with a topic which is momentum, a very important topic and a very important concept to understand the Newton's second law of motion. Okay, so let's try to understand momentum in less than 5 minutes very quickly. What is momentum? Momentum is nothing, it's a physical quantity that measures mass in motion. So anything that has mass and is in motion, it's moving, will have something called momentum. Let's look at a few examples. Now, a moving car. A moving car, of course, has mass and it's moving with a particular velocity. So this is going to have some momentum. Again, a flying aeroplane which has some mass and it's moving with certain velocity will again have momentum. Look at this athlete, she's running. Okay, again this athlete has some mass and she's running with a particular velocity. So she will also have some momentum. Now, this man sleeping, this man has mass, but the velocity of this man is 0 because the man is at rest. So this man has no momentum. Okay, so what is momentum? Momentum is basically a quantity which measures mass in motion. How do we calculate it? It's a measurable quantity of motion, and the way to calculating it is the product of mass and velocity of any object at a particular point, right? So momentum is considered at any particular point. It's very important. Momentum is what? Mass times velocity. Now, we already discussed any object that is in motion only has momentum. So object at rest, because its velocity is 0, so momentum will also be 0. Correct? What is the unit of momentum? Let's think very logically. SI unit of mass is kg. SI unit of velocity is meters per second. So momentum, which is mass times velocity, the unit would be kg times meter per second. The unit of mass times unit of velocity. So the unit of momentum is kg meters per second. Now, because velocity is a vector quantity, a very important thing that you must remember is momentum is also a vector quantity. What does that mean? That means momentum has both magnitude as well as direction, something which is very important. Please remember this. Okay, now, how does the change in mass or velocity affect our momentum? Let's look at it. Now, suppose you're standing here with a tennis ball in your hand and then your friend is standing here. Let's interchange. Your friend is standing here with a tennis ball in hand and you are standing here, right? And your friend throws this tennis ball which is of 1 kg mass with a particular velocity at you and you catch it, right? So you're going to feel some force with which you'll have to catch the ball. Now, the same scenario, but let's just change the ball to a shot put ball. Okay, now in this case, your friend throws a 5 kg shot put ball but with the same velocity at you and you catch this ball. Now tell me logically, which ball would you require more force to catch? Clearly this ball. The ball with higher mass, you will require more force to catch this ball and it will be easier to catch the tennis ball, right? That is because when when two objects of different masses are moving at the same velocity, when the mass is more, momentum of that object is more. Okay? Now let's look at another scenario. Let's keep the masses of the objects same but change the velocity. Now your friend throws the same tennis ball with 5 meters per second at you and you catch it. And then again your friend throws the tennis ball but this time with 30 meters per second velocity and now you catch it. Now in which of the following two scenarios are you going to be able to catch the ball easily? Of course the one with the smaller velocity or lower velocity, right? So what have we understood? We have understood that momentum is directly proportional to mass. That means when you increase the mass, the momentum of the object increases. When you decrease the mass, the momentum of the object decreases. When you keep the velocity constant, right? And momentum is also directly proportional to velocity. That means when you increase the velocity, your momentum increases. When you decrease the velocity, your momentum decreases as much. In the sense, if you increase the velocity 2 times, your momentum will increase 2 times. If you decrease the velocity by half, your momentum will decrease by half, right? and the sign for directly proportional is this is how you show it. Fine. Now let's look at a few real life examples of our momentum. The first is, see, if you see a collision of vehicle on the road, there are certain collision which leads to death. Unfortunately, there are certain collisions which just harm the vehicle in a minor manner and doesn't lead to major harm. What is the difference? Again, the difference is of momentum of the vehicles colliding. Let's look at it. When a road accident happens at high speed means higher velocity. Higher velocity means momentum will be high. So what it does is it is much worse, and it causes severe injuries to the passengers who are a victim of this accident, right? And when road accidents happen at low speed, what happens is, look, minor damage to the car, but then no harm to the passengers inside the car. Why? Because low momentum of the vehicle, right? And that is why it's said that we must drive slow, we must be within the speed limit, right? Speed thrills but kills. Now the next is, let's look at a bullet. A bullet has a very, very small mass, but then it is so powerful that it can pierce through a metal sheet, it can pierce through a wood, of course it can pierce through a human body and kill a person. Why? How does that happen? Again, extremely large velocity leads to very high momentum of the bullet, and that's what makes it lethal, right? These are a few real life examples of momentum. Any object that has mass and is in motion has momentum, right? You look around yourself in a daily life, you would realize that everything that's moving around you and has some mass will have some or the other momentum. It's just that we don't observe it, correct? Last example is a karate player breaking ice tiles. Now how is the karate player able to do it? Karate player is able to break the ice tiles because of its extremely fast speed. These tiles are stacked on top of each other. The player hits the tiles with very fast speed, which when it comes in contact with the topmost tile instantly comes to zero. So all the force of the hand gets transferred to these tiles, which is extremely large amount of force, and that leads to breaking of the tiles at once. Okay, that's about it on momentum. I hope momentum is clear to you. Momentum as a concept, what it is, it's nothing but the quantity of mass in motion which can be measured by the product of mass into velocity. Thank you, bache. You guys have a great day. In the next class, we're going to deal with the second law of motion.